Hey guys, hi. This is Abhishek here. How are you all doing? Doing well? All of you had an amazing day? Let's try to make it a bit more interesting. Okay? So how many of you here face a difficulty in this chapter that is called as electricity? Very strong name. How many of you face a difficulty? Let me know. Let me know in the chat. Oh, great. Amazing. I can see a lot of students actually facing difficulty in this concept. Great. But I also see, tell me how many of you are scared about this chapter? Or, you are able to do it, but somewhere or the other you go a bit wrong and lose marks there. How many of you are having that fear in your mind? Great. Great, great, great. Oh, there are many people who are like, no sir, I'm not scared at all. This is like my stream. Good job. And there are a few people who are scared also. But don't worry at all. Don't worry at all. Let's solve this problem once for and all. Okay? Now, for people who don't know me, my name is Abhishek. I'm an aerospace engineer. I'm also a master teacher at Vedantu. I have taught more than, if you notice very carefully, more than 1,000 students. And actually, I have an experience of 5+ years of teaching in physics. I love physics truly from my heart. I believe that there are many students who love physics who fell in love with physics as soon as they saw the first equation and the first concept. Correct? That's how amazing physics is. Correct? Super cool, guys. Super cool. And now, I am also an inventor of Rocket Pro course. Now, Rocket Pro is a course which is actually the only online practical learning course for rockets and aircrafts. I am personally the trainer for that. And you don't only learn the concepts of rockets and aircrafts, but also you make them by yourself. Yes, it's a practical learning course and it's also certified. So yeah, we recently launched that particular course. So keep your heads up for that course also. But today, that's not the topic. The topic here is electricity. Instead of going for the entire chapter, in completing the entire electricity chapter in 1 hour is pretty difficult. It's pretty complicated. Half of the things you will not understand, half of the things I will not be able to explain. But the best thing is, what I thought, let's try to take one particular topic where a lot of students actually face difficulty in board numericals and also a step higher in 12th standard or in JEE mains. Let's try to come down to that particular topic and clear all the doubts wherever it comes up. So, today, what and all are you going to do? Surprisingly, these are all the stuff. You are going to understand the concept of resistance in and out. I'm going to teach you the concept of resistance not only in terms of theory, but also we are going to jump into the concept of circuits. First, we'll learn the parallel circuits. Because according to me, and I believe a lot of students will understand here that the parallel circuits are relatively harder than the series circuits. It's very difficult to identify if I give you a circuit diagram, which is parallel, which is series and all those stuff. Correct. So what we'll do, we'll first understand the parallel circuit, which are a bit harder. Then we'll come down to the series circuit to understand that. But in between, we are also going to solve a lot of numericals. And in between, let me give you guys a surprise also. And I should also tell this right now, that there are going to be plenty of surprises rather than this particular surprise which I have shown it here. Correct. So please be alert on that part. Then after that surprise, we'll jump on to again the series circuit and then we'll do plenty of numericals on that also. Let me make it clear to all of you. This is going to be a lot of higher amount of energetic and interactive session. So I would like all of you to ping me the answers as soon as possible. Give your best answers to the question which I'll be putting on. Okay, I'll be allotting you some amount of time to answer me this. Cool? Great. Awesome. Awesome guys. Awesome. And also, on the way for the entire session, I'll be in between we'll be giving you tips and tricks for solving all the kinds of numericals, remembering all the concepts. So I want all of you guys to have a pen and a notebook very handy with you right now. Next to you I want it. Pen and notebook. Whatever we are going to do, note it down, solve it down. No calculators, only you, your pen and your notebook and me in front of you. Okay? So let's start this session guys with that particular concept. Okay, so starting right from the first topic for today. And before, let's jumping on the first topic, let's try to start, lighten up that mind of all of you here. So for that, let me ask you guys a very simple riddle. Okay, just to make all of you comfortable, let's put a riddle in front of you. It's a very easy question, guys. I want you guys to think about it and answer me in the chat what is the answer. The question is, feed me and I'll live, but quench my thirst and I die. What am I? What would the answer, guys? Oh, okay. Okay. Think logically and tell me. Think logically and tell me. That's all. I'll give you exactly 1 minute to solve this. Exactly 1 minute, guys. Not more than that. Start your brain ticking. Come on. You tickle your brain right now. Feed me and I live, but quench my thirst and I die. Super. I can see many of you guys answering me the correct answer also. Great, man. Great. Oh, awesome. You guys are brilliant. From the starting itself, you guys are brilliant. You kept your benchmark there right now. Let's try to raise that up. Great. Awesome. So as many of you guys told me the answer, your 1 minute is up. As many of you guys told me the answer here is nothing else but fire. You guys are amazingly correct. The answer is fire. Now, why is it important? See, the riddle stated, feed me and I live. The more you give the fuel to the fire, it's going to burn up. No matter if it is wood or petrol or diesel or whatever it is. The more the amount of fuel you're going to give to the fire, the more it burns up. Correct. It's similar to the fire of knowledge which is inside you. It is similar to the fire of curiosity which is there in each one of you. The moment you stop feeding it, that's the moment when you die. So always keep the fire of knowledge and curiosity inside you completely throughout. Great. So keeping that in your mind, be completely curious and let's start the session with the first question for all of you here. It's a very simple question. What causes resistance in a circuit? What do you think? A. Atoms. B. Positive ions. C. Impurities in the material. And D. All of the above. What do you think the answer is? Come on, give it a shot. A, B, C or D? Okay, I can see all of them, few options, A, few B, C, D. Okay, great. Final 10 seconds to answer this. Go for it. Quickly. Okay, super. I can see almost everyone is able to visualize the answer. What causes resistance in any kind of a circuit? The answer comes out to be nothing else but all of the above. The atoms inside a circuit, the positive ions inside a circuit, impurities in the material, everything combined together causes the resistance to the electrons moving forward. Still in doubt? How can all of the above be possible? Let's try to solve that particular doubt. Very simple. And also, before solving this particular doubt, today, let me show you guys this particular question. Look into the question. The previous one was relatively easy. Try understand this question. Two resistances are joined in parallel whose resultant is 6 by 8 ohms. One of the resistance wire is broken and the effective resistance becomes 2 ohms. I'm like, okay, what is happening? It was joined, now it is broken. It was in parallel. Too many information. Correct. You guys are feeling, few of you might be feeling that there are too many informations which is really difficult to comprehend. Correct? Exactly. Because that's that level kind of a question. This will come up to a level 3 kind of a question. But trust me, at the end, in the next 20 minutes, you will be able to solve this question in 2 minutes. Cool? That's what you're going to do today. So let's start. So as we were saying about the resistance, what is the exact concept of resistance? You are able to see, so imagine this is a conductor, okay? This is not imagination, this is a conductor. What imagination of? This is a conductor which is there in front of you. Now, imagine that conductor is this pen. If I tell you that in this pen, lot of atoms are there, you cannot disagree with me. Correct? Lot of atoms are there. Now, those atoms will have electrons, no disagreement again. Correct? Now, for a material to conduct, what should happen? That material must contain something called as a free electrons. Correct? Something called as a free electron. What are those free electrons? Free electrons are those electrons which are free to move. They can go for a picnic, come back from the vacation, do their job, go back again to picnic. That's the entire concept of a free electron. Correct? So, basically, free electrons are not bounded through an atom. They are free to move, not bounded to an atom. Cool. So, when these free electrons are high in number in any kind of a conductor, they are able to move from one end to another and it causes and it gives you electricity. Simple thing. Correct. Now, what is this resistance? when something inside that conductor stops the motion of these electrons. The electrons are not able to move from one end to the other. That is resistance. You are running forward and something stops you. Does not allow to move. Correct? That is resistance. Similarly, that's what happens to the electrons inside the atom or inside any conductor. So electrons are trying to move, and what are those things which are actually stopping it? The answers which you gave right now in the MCQ which I just asked. Correct? Those things are nothing else but the other atoms which are present. These are the other atoms which are present, because electrons is not only the constant inside an atom, it has proton, nucleus and all those stuff. Correct? And other atoms. So first of all, the atoms which are already constitute that particular conductor, then also other impurities. This, yellow balls you see, these are few impurities. Impurities in the sense, say if I take any material, if I'm taking this particular pen, do you agree that this pen is made up of entirely one material? Obviously not. It is not made up of entirely one material. It is made up of a mixture of materials, maybe some plastic, maybe some metal and all those stuff. Correct? But purely if I ask you, what is this pen made up of? You will tell me, sir, it's majorly made up of plastics. Correct? It's majorly made up of plastic. So the rest of the amount, imagine some 5% or 10% of amount is metal. Correct? 5 to 10% of metal is there, and that is considered to be as the impurity. In 90% of plastic, 10% of metal is being put to make it more stronger. Same way, in any kind of a conductor you take, there are some amount of impurities there. It's not 100% of copper, it's not 100% of silver, some amount of impurity, 1 to 2% or 2 to 5% of impurity there. That impurity also stops the electron to move. Correct? So you understood that there are impurities, there are some atoms which are actually stopping the electrons to move. This stopping in motion of electrons by the impurities and other atoms is called as resistance. Simple. This is the final outcome. Potential difference. Voltage is trying to push the electron. You know that because of potential difference only, your current is moving from higher potential to lower potential. So from higher potential to lower potential, your current is moving, and suddenly the resistance comes to the picture and stops it. That's what is happening in a conductor. So that is the entire concept about the resistance, guys. Solved and gave it to you in just 2 minutes. That's all you need to know. What is resistance? Resistance is the stopping force for an electron. Stopping force for an electron and also for an electric current. Simple scenario. How is this resistance caused? You understood, because of the atoms present in the conductor or any other metal, and also due to the impurities present in the metal. Combinedly, all of them tries to stop the motion of the electrons, and also by doing that, stopping the flow of current. Done? All of you understood this? Give me a quick yes that all of you have understood this or not. Very basic thing. Very basic thing. Got it, guys? Awesome. Awesome. I can see all of you got it. Amazing, guys. Amazing. Try to stick to this topic only, not go to any other topic, because this is very crucial in terms of board numericals and also for your higher standards. Completely be attentive here. So once you have understood that, then comes the complication. Now what is the complication? Complication is when you, before that, let me just ask you, how many of you guys have seen a resistor before? How many of you guys have seen a resistor before? What is a resistor? Don't answer what is a resistor. What is a resistor? Resistor is nothing but a device or a small equipment which actually provides resistance to a circuit. You add a resistor to a circuit and that resistor stops the flow of the current, giving you higher resistance in a circuit whenever you need it. You have seen it? Oh, many of you guys have seen it and many of you have not seen it. So let me show you guys what a resistor looks like. This is how the resistors actually look like. You can notice that none of the resistors on top of the written key, oh, it is 2 ohm resistor, this is 4 ohm resistor. No, nothing is written on the top of them. So how do you think we identify? How do you think we identify that? Okay, that is the resistor. How do you think we identify? Super. Exactly. I can see few of you telling me the color codes on them. Exactly. Exactly. Now this color codes also you will be, if you are taking engineering, you will be studying color codes in your engineering. If you are taking electrical engineering or any kind of an engineering, the first particular semester you will be studying about this color codes. So let's keep that for engineering. Let's not discuss that today. Okay? But basically this is the scenario. This is how a resistor looks like. Take that resistor, combine it into a circuit and you get resistance in your circuit. Cool. So that's a resistor, that's resistance. So now you know almost all things about the resistance. The complication here is this resistor can be added to a circuit in series and in parallel. Now you might be thinking, sir, what is this series? What is this parallel? Exactly. That's my question also. So let's try to understand what is this parallel thing? What is this series thing? As we stated earlier, we are going to understand first the parallel circuit. Let me show you guys a diagram. Allow me to show you guys a diagram, the actual picture of how a parallel circuit looks like. Notice very carefully. Try to identify all the equipments here. You guys are brilliant enough. Correct? So look into it. You can see, first of all, this is one resistor. Let's call it as R1. I hope you are able to identify the resistor at least. Correct? This is your resistor 2, R2, and this is your resistor 3, R3. All the three resistors are actually combined or actually put together between the two same points. Notice, pay attention. This point and this point, between these 2 points, let's call this point as point A and let's call this point as point B. Between these 2 points, all the three resistors are combined or put together. When resistances are put together in such manners, they are called as parallel circuit. Very, very important to know the definition also. Got it? I'll repeat the definition again. Please make a note of it. When two or more resistors are connected with each other between the two same points or between two end points are called as parallel circuits. So now you know the definition. Okay, now you know the definition. Now what is happening? Let's understand. How is it different from a normal circuit? Let's try to understand. Understand. What is this point, guys? What is this device here? Any guesses? What is the device? What is that equipment? Any guesses? Good. Super. That is nothing else but a battery. Amazing. Super. So that is your battery right there. What does a battery do? It maintains the potential difference. It creates a potential so that the electric current starts moving in the circuit. Correct? So let's try to see that. Here's the potential difference. Imagine that the current starts flowing through that particular line. It reaches here. Correct? From here, this particular wire, the current reaches here. This is your I exactly before the point. Now what's going to happen? As soon as it reaches this particular point, you can see that that particular point is splitted into 3 wires. So what should happen to the current? Don't you think the current should also get splitted into 3? Yes, the current must also get splitted into 3. Exactly correct. This particular current I gets splits into I1 on the first wire, splits into I2 on the second wire, and splits into I3 in the third wire. I1 goes up, I2 comes to the between, I3 goes down. Correct? Very good. Super. You have understood that. Correct? What is the takeaway from this? The takeaway is, in a parallel circuit, current gets divided. In a parallel circuit, current I gets divided. That is the takeaway from this particular concept which you have understood. So we have spoken about the current. Now let's try to talk. Now many of you thinking, sir, does it stay splitted continuously throughout? No. Look at the diagram, how beautiful it is. The current flows through all the 3 resistors and then reaches here. Correct? All the 3 resistors and reaches here. When it reaches the point B, you can see that all the 3 resistors, now all the 3 currents, I1, I2, I3 get combined to one single wire again, giving you I. And the same I then reaches the battery. What is the takeaway from this? The takeaway is the current remains same throughout the circuit. The net current is the same. 10 amperes starts from the battery, 10 amperes comes to the battery. Completely true. But in between, in a parallel circuit, it gets divided into 3. So if I assume that all the resistance are equal, if I assume that R1 is equal to R2 is equal to R3, so some 2 ohms, 2 ohms, 2 ohms. If 5 ohms, 5 ohms, 5 ohms. Imagine that all the 3 resistors are equal, then this current will get divided into equal amounts. Let's imagine 15 ampere of current is flowing through the circuit. So I1 will get split to 5 amperes, I2 will get split to 5 amperes, I3 will also get split to 5 amperes. It completely depends upon what is your resistance here. Cool? Now still, if you are facing difficulty to understand this, let me show you the actual diagram for a circuit. The same diagram which you understood and the same picture is not depicted as a circuit diagram. This is how you depict it. So from now on, whenever I show you any circuit diagram related to parallel circuit, this kind of image should come in your mind. You must be capable of imagining this particular circuit in front of you. Great job, guys. Good job. You're able to visualize this? Are you able to? Great. Awesome. Now let's talk about the circuit diagram. Same thing. R1, R2, R3 connected between two points A and B. From the battery, current I comes up. It gets splitted into 3 parts. I1, I2, I3. And then again this I1, I2, I3 combines to give you the same current I. Correct? So I'm going to write down the takeaways again. Number 1, current gets divided. Correct? Current gets divided in a parallel circuit. Let's talk about potential difference now. Okay. Now let me give you a brief. Simple thing. In CBSE 10th board numericals, what are they going to ask? They are going to ask what is the equivalent resistance. Let me repeat this again. They are going to ask what is the equivalent resistance. Also they can ask you what is the net resistance. Also they can ask you what is the total resistance. All of them mean more or less the same thing. Cool? Not only in board, in 12th board, in JEE mains, in JEE advanced, everything, everywhere they are going to ask you the same thing. And they will also specify from where to where. Beauty. Equivalent resistance. Find out the equivalent resistance between A and B. Find out. What is equivalent resistance? Simple thing. Cool. So in between A and B, find out equivalent resistance. The formula changes for a parallel circuit. Formula changes for a series circuit. We'll study about the formula in just a minute. I just want you guys to remember this. So I have found a basic method to remember this parallel circuit. Let me show you that. Look at this. This is the entire visualization. Before showing you this, let me show you guys this. What is this? This is a tank connected through 3 taps. 3 taps. Imagine this tank as the circuit. Imagine this tank as the circuit or as the battery which is actually providing the water or the current. Okay, just imagine this. Now this battery or the thing is connected to taps with the help of pipes. Consider these pipes as wires. Simple. Consider these pipes as wires. Through the pipes, water is flowing. Similarly, through the wires, current is flowing. Same thing, same analogy. Now, there are 3 taps on this particular pipes connected to each other in parallel. Connected to each other in parallel. You can see one tap is here and that tap is nothing but the resistance 1. You have the second tap. Let's call that tap as resistance 2. You have the third tap. Let's call that resistance as resistance 3. All these 3 are taps. You guys don't believe me? You guys don't believe that those are resistances? Let me tell it to you. What you do, you close this tap. You close this tap completely. Tell me whether the water is going to flow out. Whether the water is going to flow out. What do you guys think? No, right? Obviously no. Similarly, imagine this resistor has the highest resistance in that parallel circuit. Do you think current is going to flow through it? No. Got your answer? That's your analogy there. Similarly, R2 is also a resistor. Open the tap halfway, obstructing the flow of water halfway. In the third resistance, you completely open the tap up. So, no resistance at all. R3 is like minimum resistance. That's what is happening here. So, whenever you are in doubt about parallel circuit, remember this particular analogy called as water pipe analogy. And this is not a scientific name. This is a name given by me only. Okay. Water pipe analogy is given by me only. Don't take it from anywhere else. This is the analogy. Great. So remember this, guys. You will never forget what is a parallel circuit. Great. So you can see Also, it is very simple to understand here that when the water reaches here, the water will get divided into three, no? Some part will go on to this tap, somewhat will go into this tap, some water will go into through the third tap. Similarly, like a current. Simple thing, almost done. Super, great guys. You have completely understood what is parallel circuits and parallel resistance. Let me show you the final GIF for that particular part. You can notice here, this is your battery or the pump pushing the electrons to move, pushing the charges to move in a circuit. And as soon as the electrons reach here, they experience the splitting of two wires. Instead of 3, it is now 2. So when they split into 2 wires, you can see some of the current flows through this part, some of the current flows through this part, and all of them passes through the resistor here. Now as you can see, resistor is simply trying to stop the flow of current, but the current with the help of battery or with the help of potential difference still tries to cross through the resistor, but in a bit slower way, stopping it. No, so it becomes deaccelerated, it becomes slower way. Then they all come and join again. Happy family reaches to the battery again. Simple, done. That is your entire parallel circuits, guys. Now basically if you look back, you have understood what is resistance, what is the concept of resistance, you have understood what are parallel circuits with the analogy also. So there are no doubts which are kept in this particular part. The only thing which is left to understand here is the potential difference. What, sir? What happens to the potential difference? You spoke about current, but you didn't speak about potential difference V. Let me tell you that. You have, so as I told you in examinations, you are going to get what is the equivalent resistance between those 2 points. So if I take this first point as A and the second point as B, they ask you to find out the, so in between those 2 points, is there any change in the potential difference, guys? Between A and B, is there any change in potential difference? Can you find it out? How will you find it out? How will you find out what is the potential difference? What will you do? Scientifically, experimentally, you will go and connect a voltmeter. Onto the same circuit, you will go and connect a voltmeter between A and B. Correct? Between A and B, you have connected. Now they will ask you what is the change in potential difference with all the resistors. For R1, what is the potential? For R2, what is the potential? And R3, what is the potential? Now my question to all of you is the potential difference equal for all R1, R2 and R3? Are they equal? What would your answer? Great. Awesome. Awesome. I can see many of you guys tell me, yes sir, they are equal. You are damn right. You are damn right. You are amazing. You guys are brilliant guys. Super. Exactly. Because potential difference is calculated between this point and this point, A and B, which constitutes the entire resistance. So for individual resistances, potential difference is not going to change. But also if you have a doubt, what you can do is connect the potential difference here separately for this particular resistor, connect it to this particular resistor separately, and also connect it to the first resistor separately, connect the voltmeter separately and check. Connect the potential difference separately, and if you still have a doubt, you will find out that all the potential differences at R1, R2, R3, all of them are exactly equal to each other. Got my point? So what is the takeaway? The takeaway is current gets divided. Potential difference, no, remains constant across a parallel circuit. Done case scenario, done. Not a doubt at all. Correct. Now since you have understood that part, the only thing which is left to find out the formula. Cool? Let's find out the formula. You have, see, let's take Ohm's law. I believe you guys know what is Ohm's law. You guys are brilliant enough to know. Like, if you don't know, let me tell you that. The Ohm's law states that the potential difference, or let me start with the current part. The Ohm's law states that the current flowing through any circuit, this same current I flowing through any circuit is directly proportional to the potential difference applied across the circuit. That is B directly proportional to I. Applied across the circuit by what? By the potential difference V. Cool? Awesome. Understood? I'm going to repeat it again. Make a note of it. The current flowing through a circuit is directly proportional to the potential difference applied across the circuit. So guys, wonderfully done. You have understood the Ohm's law. And once you get the final formula, what is the final formula, guys? Yes, I already saw many of you guys put the answers. So it is actually V is equal to IR. Yes, guys, that is the final formula for this. Okay, so you got it. Completely cool. Awesome. So let us use the same formula here to find out the derivation. Here you can see we have written I is equal to V by RT. Same formula. Instead of V is equal to IR, I have written I is equal to V by RT. And RP is what? RP is the equivalent resistance of the parallel circuit. That's why RP. So let me name that as RP. That is nothing but parallel circuit resistance. The equivalent, the total resistance. Okay. Now, you know that the current flowing through a parallel circuit is same. Correct. So current entering the parallel circuit and current going through the parallel circuit is same. So that means we can use this formula here. That is I is equal to I1 plus I2 plus I3. All the current which got splitted up, they're automatically or they're anyways equal to I. Cool. So instead of I, I'll put the value of Ohm's law giving me V by RP. And instead of all the individuals I'll put individual Ohm's law there. So I1 can be written as V by R1, I2 can be written as V by R2, I3 can be written as V by R3. Why am I not writing V1, V2 and V3? Because the potential difference is exactly the potential difference is constant. So I no need to write V1, V2, V3. They are equal in all the three resistors. But only thing what is changing is the R1, R2, R3. Resistance are changing. So that's why I write down R1, R2, R3. Now, if you notice very carefully here, I can cut out V from the equation and I'm left out with the final formula for this particular parallel circuit. Please make a note of it right now. The question is 1 by RP is equal to 1 by R1 plus 1 by R2 plus 1 by R3, and it keeps on going depending upon how many resistors you have it in a parallel circuit. Simple as that. So that is your final formula, guys, for parallel circuit. That's it. That's the end of the theory of parallel circuits. Now let's go have some fun about it. Let's go have some fun. So first thing first, as I told you, in the next 20 minutes you'll be solving one problem, correct? Now it's exactly that 20 minutes. So now I'm going to show you the same problem. I'm going to give you exactly 2 minutes to solve it and you will be able to do it. If you're not able to do it, don't worry. We will do it together. Simple. Okay? First question. Yeah. Basically, let me tell you how to calculate also before you go into that. So as if you, these are parallel circuit, 4 ohm connected together, 4 ohm, 4 ohm. How do you do it? You write down 1 by 4 plus 1 by 4 will give you your 1 by RP. Correct? So when you calculate this, you will get 1 by RP is equal to 2 by 4, right? Which will give you 1 cancel, 2 you will get 1 by 2. So your RP will be nothing but your 2 ohms. Correct? You do the reciprocal. Similarly, 1 by 6 plus 1 by 6, you will ultimately get 3 ohms. 12 by 12, you will get 6 ohms. Correct? Let me do the third one also if you are confused with 1 by R1, which is this, plus 1 by R2. So 1 by R2 gives you equal to 1 by RP. Correct? So this will, by solving it, that is 1 by 12 plus 1 by 12, you must get an answer that would be 2 by 12. So that will give you 1 by 6. So your 1 by RP is equal to 1 by 6. So what is your RP equal to? RP is equal to 6 ohms. That is your equivalent resistance. That easy. Okay. Simply apply the formula. Go for the mathematical approach. Done case. Great, guys. So going to show you guys the question now. Going to give you exactly 2 minutes to solve it. The question is here. Go for it. Now read the question very, very carefully. Try to visualize. Try what I said. Draw a diagram. You will approach it. The first thing which you should do in any kind of a resistance circuit is to draw the diagram. Your 2 minutes has started, guys. Try visualizing. Try visualizing it. Try visualizing. Simple scenario. Two resistance are joined in parallel. First hint given to you. Whose resultant is 6 by 8 ohms. Come on, I hope you guys can visualize that part, and they are giving the hints also in the question. Let me tell you, 70% of the answer is there in the question. Then it says, one of the resistance wire is broken and the effective resistance becomes 2 ohms. Then the resistance in ohm of the wire that got broken was how much, guys? A, B, C or D? 3 by 5 ohms, 3 ohms, 6 by 5 ohms or 2 ohms? What will be your answer? What do you think? Show me what you got. Show me what you got, guys. Show me. Come on. Interesting. अच्छा, ठीक है. Great. I'm very proud. Actually, I'm very proud of all of you. Doing amazingly well. क्या बात. Okay. Super. Super. 1 more minute left to do it. 1 more minute. Just 1 more minute. You guys are doing crazy good. You guys are doing crazy good. I can already see few correct answers coming up. And few wrong answers also, always. That's not a problem. Don't worry. We'll solve it. We'll solve it. Good job. Great. 30 seconds more. 30 seconds more. Your time is running out. 30 seconds more. Come on, guys. Quickly. Quickly. And 20 more seconds. Oh, yes. Oh, yes. Results ki ghadi. Come on. Come on. Great. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Your time's up, guys. Your time's up. I hope all of you did it. And congratulations, man. Congratulations. You guys did an amazing job. I want everyone to clap for each other. You guys are doing amazingly well. I appreciate. I'm really proud of all of you. Good job. So let's try to visualize it in my way. Okay, let's try to visualize it in my way. And there's a small surprise in this question. There's a small surprise in this question. I'll tell you what is that surprise. Okay. Hold on with me for just 1 second. Let me just, redo the diagram. I hope you guys have made a diagram. So they state there are two resistances. Sorry for my diagram skills are very bad. Obviously, caution you, in the starting itself. This is your resistance R1, this is a resistance R2 connected in parallel. That's what they ask you. So let's consider this point as point A, consider this point as point B. So R1 and R2 are connected with each other, as simple as that. Now they said that the equivalent resistance, that is, guys, simple. They tell us that the combined resistance, total resistance or the net resistance is equal to 6 by 8 ohms. And what is that? That is nothing else but your RP. So this is the bottoms up approach. They have given you the equivalent resistance. They are asking us to find out something else. What is that something else? The rest of the question tells you, very importantly, the rest of the question tells you, now what has happened ki, one of the resistance are broken. So let's imagine that R1 is broken. So if I imagine this point as A again, going here, R2 comes down without any difficulty because it's still attached to the connection. This is R2, but R1 is broken from up. Simple. R1 is here. It's broken out of the circuit. So now I want you guys to visualize and tell me, think and tell me, will any current flow through this particular wire? Imagine current is coming from this direction or through that particular point A. Will any current flow through this wire R1? Your answer must be exactly correct, guys. No. No current is going to flow. Probably be broken. And the effective resistance becomes 2 ohms. So after the resistance is broken, they tell you that the R2 resistance, the complete resistance of the circuit is now 2 ohms. Entirely through or the equivalent resistance in that particular circuit is only R2, which is equal to 2 ohms. Because R1 is out of order. It's not working. So guys, you have almost got the answer now. Correct. Let's apply the formula. Simply 1 by Rp is equal to 1 by R1 plus 1 by R2. Done. Correct. So 1 by Rp is given to you. 1 by R2. R2 also you know. R1 you need to find. You need to know what is this resistance here. Let's try to find it out. So if we apply here 1 by R1, let's make an equation for 1 by R1, which will be equal to 1 by Rp minus 1 by R2. Correct. So 1 by R1 will be equal to nothing but 6 by 8. So it becomes 8 by 6. Correct. Let me write it down. 6 by 8 minus 1 by R2 is nothing but how much? 2. Cool. Let me take a new page. So that 6 by 8 guys will become 8 by 6. Correct. You guys are intelligent enough for that. So it becomes 8 by 6 minus 1 by 2. Let's try to do the LCM and get what is R1. You will get 16 minus 6 divided by 6 into 2. This is how I take LCM, so don't worry if you get confused there. No, this is how I make LCM. Take it. So 16 minus 6 is 10 divided by 6 into 2. So 2 ones are and 2 fives are. You are getting an answer 1 by R1 is equal to 5 by 6. Let's find out what is R1. R1 is going to be 6 by 5. Don't you think that is the correct answer? Let's go back to the options and see. Yes, ultimately option C is the correct answer. That is 6 by 5 ohms. Well done. Well done guys. Well done. Awesome. Really happy for all of you. Now as I told you that there is a surprise. What is that surprise? This question which you guys just solved. This is not a CBSE 10th numerical. No. This is not even a CBSE 12th numerical. No, it is a JEE mains problem. Think about it. After understanding the concept, the first question which you were successfully able to solve was that higher level question. So from now on, whatever questions you solve in CBSE 10th and all will be like bacha, will be like kids for you. Correct. So that is the power of understanding the concept completely in and out. And congratulations guys, you have solved that JEE mains. Well, I'm really happy. Now, as I told you in the starting, after doing one numerical, there is one bigger surprise for you. The bigger surprise is guys, Vedantu now has come up with an amazing course only and only dedicated to this particular chapter, electricity. And I would be personally handling this particular chapter for all of you who will be joining the course. And I believe that almost all of you will be joining. Because I'm really high. I can see the enthusiasm in all of you. I can see the, that energy inside you to learn electricity. Good job guys, good job. Very amazing. So right now, as you guys notice here, it's going to be a live online interactive class, completely interactive. You guys can see how much interactive we are right now. You are going to get study materials related to the particular chapter. You are also going to get the handwritten lecture notes. See, there are things which I'm writing right now. All those things will be provided to you as notes, and 24/7 doubt solving will be there, guys. 24/7. We will be connected through our WhatsApp group completely 24/7. You can ask me any doubts related to electricity chapter whenever you want, and I'll be attending to that doubt completely. So we are going to be in touch for 24 hours, 24/7 hours completely. Correct. And as I told you already about this lecture notes, that is different. But in between and all, we'll be not only solving the CBSE 10th numericals, not only 12th as I told you, we'll be attempting JEE mains also. Okay. Let's target the highest point, because the bottommost points will become easy then for you. Obviously, we'll solve CBSE 10th, but let's target JEE mains also. Let's make it more interesting. If you guys don't know about it, many students, many aspirants of JEE, IIT and all, what they do basically is that they learn really hard this kind of problems, the resistance related problems, electricity related problems. In 10th standard itself, they keep their basics completely clear. So that in 12th standard and all, and during JEE main preparation, they don't have to work hard that time. And that's a really good strategy. That's an amazing strategy. So keep your basics clear, keep your conscience clear regarding this particular concept, and you will be rocking in the IT aspirants if you are wishing to go for ITs. Correct? Great. Super guys. So that will be done, and it will be taught by me, as I told you already. What are we going to cover in this particular concept? First of all, we'll go and understand the complete concept of electric current, potential difference, circuit diagrams. I saw in the starting in the chats here, many of you guys were asking, sir, what is potential difference? What is potential? Correct. That doubts are there. So let me clear that up for all of you. We will be learning that in deep in this particular course. Then we'll go and understand the significance of Ohm's law, not only through numericals or not only through, proper concepts, but we'll also understand through what is happening in real life by using Ohm's law. That's going to be amazing. You will be able to know where is this Ohm's law, and all those things which you're learning are applied in the life, in your real life, for all the concepts. Cool. And then obviously the king of the chapter, resistance, will be covered in the question, and we'll do plenty of numericals and all. Then we'll understand the power concept, power circuits, and heating effect of current very, very in detail. We'll do a complete analysis out of it. Cool. Now, the best surprise for all of you is, after this course, as you can see, after this particular session, the students who are registering within 4 hours are going to get a lightning deal. That lightning deal will be for 1,000 rupees. This course is for about 6 to 7 hours. If I'm not wrong, it's about 6 to 7 hours. And the entire chapter will be covered up to the JEE mains level, as I told you. And that price for course right now is just 1,000 rupees for the next 4 hours, guys. For the next 4 hours. As you can see, the time is still ticking. And if you're buying the course after this particular part, after the lightning deal is done, then you will be getting the course for 1,999 or 2,000 rupees. So hurry up, join now, and let's see the magic of electricity in our regular sessions. Okay? All those stuff apart, let's go back and learn something. Let's go back and learn something, guys. So since we have done this particular problem, let us try to solving one more JEE main problem. But before solving the JEE main problem, as I promised you, parallel circuits are done. Let's talk about series circuits now. Papa, small boy, let's try to find out what is series circuit. Look into the circuit diagram. So yeah, people, I forgot to say this. This is the link to visit that web page which I just showed you. Okay, please copy this link right now. It is https://vdnt.in/2vwm4. Please copy paste it, or you can make a note of it right now. I'll give you 10 seconds to make a note of it right now. Please quickly make it. And it is case sensitive. It is case sensitive. Capital letters, small letters, correct. No discrepancies in that. Do not differentiate. Do not discriminate. Take it, write it down. Great, guys. Super. Amazing. Cool. Now, one more thing. The reason why I think we are doing this in YouTube is because you can again and again watch the YouTube video how much ever you can. You can share it how much ever you can. You can like it how much ever you can. They keep doing that, no? So that's the reason why we brought it to YouTube. I saw many questions being asked why it is on YouTube and all. That's it. So, you can stop also. You can replay also in your convenience, correct? So if you have any doubts till now, you can replay the part which we were just studying. Watch it twice, done. No problems. I believe no one will have that particular condition here, and almost all of you have understood. Cool, guys. So I hope you have made a note of it. Let's go for the series circuit concept. Look into this particular part. This is your series circuit. Obviously, this is a series circuit. What is the difference which you notice? The first difference which you notice here is the connection doesn't look like parallel, sir. Obviously, yes. This is not parallel. This is series. If you notice very clearly, I have one resistance R1 here. Correct? I have another resistance R2 and R3. They are not connected one above the other. They are connected in a straight line, one after the other. One end of the first resistor is connected to one end of the second resistor, and then it goes like a chain. Correct? It goes like a chain. So what do we notice here? We notice that this is a series circuit. That's why we call it as a series circuit, because they're connected in series, one after the other. That is what called as a series. So that is the takeaway. And bit more, as I spoke about current and potential difference there in the parallel circuit, let me speak about that right now also. Let's talk about a series circuit. In a series circuit, if you notice, this is your battery. I hope everyone can identify that right now. Correct? That is your battery. From the battery, current comes up. Current aa raha hai. It reached here. Current पहुंच गया. Let's make a joint here. ठीक है? Let's make a joint here. Current वहां पहुंच चुका है. Now current is thinking there is no split. You are also thinking, sir, there is no split. So is my current going to split into 3 or split into 2 or split in anyhow possible? No. There are no branches at all. No splitting required. So the current starts flowing to resistor R1, passes through R1, comes down, goes to R2, passes to R2, comes down, goes to R3, comes down, and the same current flows through here. What do you take away from this? You take away that the current in a series circuit is constant. It doesn't get divided at all. That is your takeaway. Right? Let's talk about potential difference, sir. What happens to potential difference? Now think about it. They ask you that find out what is the potential difference across R1. How will you find it out? What will you do? You will connect one wire here, another wire here, and connect a voltmeter. You measure the potential difference there. Correct? So now you notice that the other two resistors are not falling between the same 2 points. You need to change the connection of voltmeter continuously one after the other to find out the potential difference. Correct? In that particular scenario, it is very easy to imagine right now that obviously, sir, potential difference is not going to be the same because all the three are not in the same 2 points. If I was measuring between the same 2 points, potential difference between those 2 points are same. So resistors falling inside that will have the same potential. But right now the potential is 1 here, 2 here, 3 here. Continuously different with each other. Correct? Exactly correct. So what you notice here is that the potential difference gets divided in the case of a series. Let's take a circuit diagram. The same circuit diagram which you saw here. R1 1 resistor, R2 1 resistor, R3 1 resistor. Same current flowing through all of them. Constant potential difference. You find a potential difference through V1 between 2 points, V2 again between 2 points, V3 again between 2 points. When you add all of them up, V1 plus V2 plus V3, you will get the entire potential difference, that is V. So here I can write down that V is actually equal to V1 plus V2 plus V3 and your I is equal to a constant value. 15 amperes, 10 amperes, so whatever it is, it does not get divided. So that's it. That's the takeaway. Done case, done scenario. Let's look into a GIF also. Look into this. Very careful, look into this. This is the entire GIF. The current is pumped through the battery, flows through the circuit, comes and touches your resistance R1, then touches your resistance R2, goes straight way. So the same current coming from this particular wire passes through this resistance also, passes through this resistance also, then gets combined here. So there is no splitting of current here. There is no splitting. Same current flows through all the resistance. So your I again becomes constant, but the potential at R1 and potential at R2 becomes different. Potential difference at 2 points are different. That you know. Great. Awesome guys. Super. So keeping that in mind, let's try the analogy also. Let's try to do the analogy also. Water pipe analogy. Discovered by Mr. Abhishek and all of you. Correct? So you have the battery again. Water flowing through the pipe. The taps connected in series instead of parallel. Correct? You stop one of the tap. Will the current flow through any of them? No. You will be like, Enga, I'm not going to give you current. Exactly. Correct? Super. So yeah, if you open up the first tap, the water flows through tap 2 and tap 3. Correct? The same water flowing through tap 1 will reach the amount of water. Imagine 10 liters of water is flowing through tap 1. The same 10 liters will reach tap 2 also. The same 10 liters will reach tap 3 also. Same current flows through them. Similarly, got it? That's the water pipe analogy for all of you here. Now, on this particular terms, let's try to find out the formula for now your series. So here, as you notice, we have taken the Ohm's law again. V is equal to IRS. What is that RS? RS again, your equivalent series resistance. Equivalent, please make a note of it. Do a mistake here. Equivalent series resistance is your RS. So you got your equivalent series resistance. V is equal to IRS. Now you know that we can write down V is equal to V1 plus V2 plus V3 for this particular scenario. Awesome, super cool, done case. So now, instead of V, I'll write down IRS. Correct, that's what you found out. No, V is equal to IRS. We've done that. Now instead of V1, V2 and V3, at all the places, we will write down the Ohm's law. Same thing which we did for parallel circuit. So we have written IR1 plus IR2 plus IR3. If you notice very carefully here, again, I remains constant, so I have not used the subscript 1, 2 and 3 for I. But resistance are different, that's why I used R1, R2 and R3 for all of them. So that's done. So that's the done scenario. Now similarly, IRS I can take common on the right hand side. I took common R1 R plus R2 plus R3 inside the bracket. Then we can cancel out this I and the right hand side I and will only rest up with RS is equal to R1 plus R2 plus R3. Look at that. How easy is that? RS has come out to be R1 plus R2 plus R3. Look at that. It's not even reciprocal. You don't even have to divide. Just add all of them up. R1 plus R2 plus R3 will give you your answer. Correct. For example, if two resistances, 6 ohms and 6 ohms are connected in series, add them up. 6 plus 6, 12. 3 resistances, 6 plus 6 plus 6, add them up. 18. 4 resistors, 6 plus 6 plus 6 plus 6. Add them up. 24 ohms. Not at all. Cool? Got that point? Now, going on to a scenario where I need to tell this right now. Because many students, if I tell you, out of 100, about 40 students will not know how to differentiate between a parallel circuit and series circuit. But we have already learned this. Correct. Please remember always this guys, that whenever you see a parallel circuit, if you're not able to identify it, look for the joint. Is there a wire joint? Is there a joint from where the current is getting splitted up? That will be your parallel circuit. Take it from me. No doubts at all. If more than two branches are coming out, two or more than two branches are coming out from a single joint, that is your parallel circuit. Cool. Now what about series? Series so is simple. No joints at all. There are no joints at all. Jahan se the current will be splitted. If the current is not splitting, then definitely it's the series circuit. Keep this in your mind, write it now if you want. This is how you identify. Because few parallel circuits which they come are there like, oh, gone case. Okay. Now, let's try to solve a problem on this particular grounds. Chalo. Here is a question. Again, a JEE main question. No doubts about it. JEE main question. 3 resistors, each of 2 ohm, are connected together in a triangular shape. The resistance between any 2 vertices will be how much? Vertices, I hope you guys know. This is a triangle. These are called as the vertices. Find out the resistance between any 2 vertices. Go for it. I'll give you exactly 1 minute to solve because that's the time it takes to solve. Go for it. Come on guys. Give your best. Great. Come on. Still waiting. Do not guess, sir. Do not guess. Try to solve it. Because anyways we'll solve it. So I can see the chat here. I can see if you will are guessing and answering. No. Don't do that. No guessing. Go here. Come on, quickly. 30 more seconds. Kar lo jo karna. Do or die, guys. 25 seconds. It's like a time bomb, right? It's like a time bomb. It goes from 25 seconds left for your death. 20 seconds more. Okay. I can see few answers coming up right now. Good job. I'm not sure whether it is right or not, but good job. Okay. 5, 4, 3, 2, 1. Your time's up, guys. Time's up. Focus here. Focus here completely. I could see not everyone is able to answer this correctly. You don't know the correct answer. That's because you guys are going wrong in one particular part. Let me tell you that which is that particular part. See, according to you, whatever you have learned, according to that you give me the answer. I'm really proud of you. But I can see one doubt is still left there. One thing which you don't know. Let me clear that up. Okay? Let me clear that up. So, let me draw a diagram for this. 3 resistors, each of 2 ohm. No. So, sorry for my diagram again. This is your first resistor. Oh my god, it looks like something. Okay. This is your second resistor. And this is your third resistor. Correct. And all the 3 resistors are connected as a triangle. That's what they have told you. So, let's call this point as point A. Call this point as point B. And let's call this point as point C. Super. Okay. Now they are asking you to find out the equivalent resistance between any 2 vertices. कोई भी vertice, कोई भी 2 ले लो, जिसके through बताना है आपको कि कितना resistance है. ठीक है? So for our convenience and since Abhishek is my name, let's go for AB. ठीक है? Between these 2 points, we'll find out the equivalent resistance. Now, how is the circuit connected? How is the circuit connected, guys? They are in series. No, all the 3 are in series. You agree with me? Correct? Super, super. I can see many saying, yes sir, it is series. No, it is not in series. All the 3 are not in series. This is what you need to know right now. This kind of questions come in the board examination. 10th also, 12th also, JEE mains also. Correct? So, why it is not the parallel circuit, series circuit? Why it is parallel also? Listen to me very carefully. Guys, these 2 are in series. Let's call this R1 and R2. These 2 are in series because if I assume that current is flowing from here, it reaches here without, there are no branches. No, one goes inside, one goes outside. So there are no branches. So yes, it is really good to assume that it is in series. But now similarly you will tell me, sir, it goes here, it comes here. No. No. Why? Because they are asked us to find out what is the potential difference between this point A and this B. Here comes the complication. When they ask you to find out the potential difference between that two points, this entire thing above it becomes parallel to this one. How? Let's do one thing. To find out the potential difference here, you connect one wire. Correct. This is your wire. Current is starting from here, going from here. Correct. Forget about the potential difference. You notice here, current is entering through A. Correct. And it gets splits into two here. Current is coming from above. And then from here also it is coming. And both of this combine here. So if current I is flowing through here, current I is coming out. But you notice that A and B at that particular points, the current is getting splitted and combined. So what are these 2 points? These 2 points becomes a joint. This is what you need to know throughout your life. ठीक है? तो जब भी, कभी भी similar kind of question comes, just remember how is the current entering the circuit, how is the current leaving the circuit. So if you are able to imagine that very clearly, you will be able to solve any kind of a problem. I'll give you one more problem, don't worry about it. So current is flowing through, entering through A, gets split into 2, coming at B, split into 2. So if I imagine this is I1, this is I2, correct? I1 flows, same flows here, so I1 through here, and here I2 comes in, I1 and I2 combine and give you I again. Correct? Simple. So above 2 are in series and this one is in parallel. Correct. Now let's try to do the problem. So this is your 2 ohms. This is also your 2 ohms. This is also 2 ohms. Correct. So now solving R1 and R2. Simple. R1 plus R2 will be equal to your RS. So 2 ohms plus 2 ohms will be equal to your 4 ohms. No doubts. So we have got the RS. Correct. Which is equal to your RS. Now this RS. Now once you have solved that particular part, draw the diagram again. Very important. Draw the diagram again. So diagram now will look like A here. Okay. And the parallel circuits, series circuit solved above, giving you RS here, which is equal to 4 ohms. Cool. And point B here. And still this one is left here with its 2 ohms. Correct. Let's try to solve it now. So this will be 1 by RS plus 1 by R3, which will be equal to 1 by RP. Correct? Let's take a new page. So RS will be nothing but 1 by 4 plus 1 by 2, which is equal to your 1 by RP. So your 1 by RP will be equal to 2 plus 4 divided by 2 into 4. I find out LCM by cross multiplication. Really sorry if you are not able to understand that. Don't worry. Go find your LCM by your way you want. Okay? So 6 divided by 2 into 4. So 2 ones are and 2 threes are. So your answer is 1 by RP is equal to 3 by 4. So your RP is nothing but 4 by 3, I suppose. 4 by 3 ohms. Is there any calculation mistake? 2 plus 4 divided by 2 into 4. Okay. 6 divided by 2 into 4. 2 ones are 2 threes are 3 by 4. RP 4 by 3. Was there an option for that? Oh yes, there was an option. 4 by 3 ohms. And once again, you guys have solved the JEE questions. Well done. Amazing. Super. Great guys. Similarly on that terms, I would like to give you guys a homework. Okay. Before that homework, I would like you guys to find out the equivalent resistance here. Apply the same thing. Try doing something. This is a very beautiful problem. Try to do the same thing. It's a very, very, very beautiful problem. It has come in board examination, has come also in JEE Mains. Find it out. Apply the same thing where you can make a joint. Try to find out how the current is flowing. Equivalent resistance between A and B is what they're asking. This is your A, that is your B. Try to find out how is the current going to enter and how the current is going to go out. I'll give you exactly 1 minute to solve this. The time has already started. Go for it guys, go for it. Give your best. Give your best, go for this. I know the webinar is going 5 minutes extra, but it's worth it. Trust me. Go for it guys. 1 minute. Option A, B, C and D. Again guesses are. Few guesses I can already see. Essay. Come on. 40 more seconds. 40 more seconds. Even if you're not able to solve it, try to visualize. Try to see, sir, where is the joint here? Is there a joint here? Can I solve this? Try to visualize that, because that's the hardest part. The moment you are able to imagine the scenario, to visualize the scenario, that's a done deal, guys. That's a done deal. Go for it. Good. 15 more seconds. Let's try to solve it in 2 minutes. 15 more seconds. 10 more seconds. Great. I can see many of you guys giving me the correct answer also. Well done, super. 5, 4, 3, 2, 1. Your time's up. Okay, let's see how to solve this, guys. Listen to me very carefully. Pay attention. It's a very crucial problem. Look into it. If you understood this, all the other problems are super easy for you. Okay? Look into this. So they're asking us to find out what is the distance between A and B. What is our thing? We'll make a diagram here. Okay? We'll connect a wire here, current flowing inward, current going outward. Current, as soon as it reaches A, it flows through here, flows through here, flows through here. Correct? So I1 here, I2 here, I3 here. So the same current I1 flows through here, I2 comes through here, I3 comes through here. Okay? And all of them combine again here to give you I, and then it comes out of point B. Correct? At that point A, the current got splitted into 3, I1, I2, I3. I1 flows through 3 ohms, I2 flows through 2 ohms, I3 flows through here 4 ohms. All of them combine here to give you 6 ohms. Correct? Super. So now you have got it. What does that imply? You are able to understand that right now, since, sir, the current is getting splitted here. Don't you think that 2 ohms, 3 ohms and 4 ohms are in parallel to each other? And 6 ohms also are parallel to each other. Correct? Correct? So let's try to make a simple diagram for this. Okay. Let's first make that 6 ohms separately out. This is your 6 ohms. Here is your point B. Here is my point A. From my point A, the current is entering. It got splitted. It got splitted. And it got splitted. Correct? Here it got splitted. None of the other things splitted. And here you have one resistance. That resistance is 3 ohms. Correct? Super cool. And this resistance is again how much? 2 ohms, I believe. Yes, 2 ohms. Correct? And this resistance again at the bottom is your 4 ohms. Now if you notice very clearly, all the 3 resistances are attached to this particular point, which is attached to 6 ohms. Correct? Same thing I'll draw it here also. Same thing I'll draw it here. All of them 3 are attached to one common point, and that point is attached to 6 ohms. So what we did? We converted that circular circuit into a normal parallel and series circuit. Correct? That's how easy it becomes when you're able to visualize it. When you understand, okay, where is the joint? Where are the joints? How is the current flowing? Yes. If you are able to visualize how is the current flowing, that's done, guys. You are God now. You are an expert now for solving electricity. Okay? Now, if you believe what is the answer for this? See, if you have understood this, the rest of them is mathematics. Correct? So you'll go for 1 by 3 plus 1 by 2 plus 1 by 4, giving me equal to 1 by Rp. Correct? So let me try solving it. I'm not pretty sure how much it would be, but I'm sure enough it will come out to be, 1 second, 8 plus 12 plus 6 divided by 8 into 2 into 4, which will nothing but 26 divided by 8 into 2 into 4. So 2 ones are, 2 ones are, and 2 threes are. Correct? So 13 divided by 8 into 4. So your answer somewhere here is 1 by Rp is equal to 13 divided by 24. So your Rp will come out to be equal to 24 by 13. Is that correct? I'm not. Oh, 1 second. It's 4 threes are. Oh, 4 is 8 plus 4 is 12 plus 6 divided by 8. Oh, this is 3 into 2 into 4. My mistake. My mistake is 3 into 2. Correct. So it's only 4 3 is 12. My mistake. Yes. So you will get 12 by 13. Super. So Rp will be equal to what? Somewhere about 0.92, I believe. Correct. Rp is equal to 0.92 ohms. So yeah, that's done. Now once you do that, what you need to do? You need to draw the diagram to make it more clear. And it's a very important thing for the CBSE board examination, otherwise you will not get marks. You need to draw the diagrams. So A done, and you all combined it to RP. RP is equal to now 0.92 ohms. That is then connected to your 6 ohms. Done. Which is here connected to B. Current going out. Both of them in series. So RP plus 6 ohms. What is the answer? That is equal to RS. So RS is equal to 0.92 plus 6 ohms, giving the final answer as 6.92 ohms. And you are done. You solved one of the most crucial questions which has come into CBSE board examinations. Look into here. Exactly correct. 6.92 ohms is the answer. Well done, guys. Well done. I really congratulate you guys. Appreciate all the efforts you have put in this particular session, keeping a notebook, your pen, and doing the sums with me. I really appreciate it. Thanks a lot, guys. Thanks a lot. And also, one final time. As you guys know, the course has been still running. Okay? So I have already given you the link. So try going back again to the link, and I hope you guys have made a note of it. Try joining the courses. We are going to have super fun in these sessions. In-depth analysis. Complete. In this 1 hour session, we went into as much as depth possible. Okay? But let's try to go in way more depth possible in your electricity chapter in our courses in just 7 hours. Okay? And one more thing, as I promised all of you, I'm going to give you guys one homework. This is my contact number and my email ID. I don't usually pick up calls from unknown numbers, but I definitely text them back. Okay? So if you guys have any doubts related to this kind of electricity problems and electricity concept, please send me a text on WhatsApp. I'm readily available. You can also send me an email on this particular email ID with your doubts. And one thing for sure, you need to send me the answer of this homework which I'm showing you right now. I want the answer for this homework no matter what, within 1 day. I'm going to give you guys exactly 1 day, within 24 hours. I want to see how many of you guys can solve it and send it to me, this particular question. This is again a board problem, also has come into the JEE mains, so it's completely on you. Okay? In 24 hours, these are the 4 options in front of you. Go for it and solve it. Try to visualize the scenario, try to find out the joint, try to see how the current flows through each and every circuit, and you will be the expert for resistance problems. Great, guys. So in 24 hours, please make a note of it. This is my WhatsApp number. This is my email ID. Send me the solutions. Let me see who sends me the answers first. Great. So with that note in mind, guys, we'll end the session right now. I hope you have made a note of this links and also the link of the previous one, the course page. Go for it. And everyone, thank you. Thanks a lot. Great.